Good day, I'm Shashmita Lakshmi. Today me and Prakash going to conduct server closed loop speed control experiment. First of all, I would like to explain the objective. The objective of the experiment is to be familiar with server operation in closed loop speed control. Next, be able to calculate and measure the steady state speed of the digital servo in closed loop speed control of various controller, gain both theoretically and mathematically, and able to compare both of them.
Good morning, I am Prakash Ramakrishnan. Today I am going to explain about servo closed loop speed control. So for this experiment, we need to understand the basic block diagram from the control instruction subset. So for the block diagram, for example, so if I input in this computer by software, this software will work out to the servo controller, and this servo controller will function to the motor transfer function, and this motor will transfer to the computer and get the result. This is basic block diagram function. Okay, so we straight away go to the procedure and set up connections, everything. So first, please come. So first, set up the server system for the speed control, disengage the platform. Okay, this is actually platform, the linear axis. Set the belt tension. This belt tension we have to untie. So we pull out from the shaft because we don't want the function. We don't want the connected with this. Secure the flywheel shafted above the action ST. So yeah, remove it. Okay. So second, run LV servo and click the device controller. This is LV servo system. So now we click on the device controller speed loop. Okay, so this is our table. This input we need to input in this software. So for example, single signal type in constant, and offset 0%, and power is later. So now I have to offer off. So later the last option we need to offer. And PID controller gain, the gain controller must be 1, and integral time off, then derivative time on 0, so and next derivative time on PV, it's 0, and 10 millisecond. Anti-reset wind up on, upper limit 100%, lower limit minus 100%, and open loop or closed loop we need to close loop because this experiment servo closed loop for speed control. Okay, so it's a closed, and trend recorder. So 3000 RPM. Trace recorder checked. Okay. Reference checked. Speed checked. Current unchecked. Voltage unchecked. Sorry. Error unchecked. Gain controller times error unchecked. So until PID output unchecked. So this one display sweep. Show and record data. So gain 3740. So now we can on power on. Okay, for example, for the table, so here the speed. Okay, for the second, so before the switch on, we need to refer our measure table. So this is our input. So when we input the 40, so we input the offset to here. So the speed will get, so the motor will run here. The motor will run here. So that we can find it because we install and connect. And this is result, the speed result. So after this we have to calculate by measuring. We have to calculate everything and we input in measuring table.
Next, we would like to explain the observation from the data of the experiment. The reference speed will make the steady state speed increases too. After that, the more reference speed, the more steady state speed ratio. The maximum state ratio in this experiment is 282.74 with the 90 reference speed. The maximum steady state ratio is gain 5, which is 153.94. The maximum speed voltage in gain 1, which is 6.68, and the minimum speed voltage in gain 5 is 6.47. From the data, we also can observe the value of calculated and measured steady speed are different.
As conclusion, from this experiment, we familiarize ourselves with servo system operation in closed loop speed control. We also learn how to calculate and measure the steady state speed of the digital servo in closed loop speed control. Then we also learn to calculate the error value between the reference speed and the actual speed, how to minimize it by increasing the controller gain. Thank you.